So you're excited to dive into local AI, right? But then you see a file name and it looks like absolute gibberish. Trust me, you are not alone. Today we're going to crack that code. Let's get into it.
I mean, look at this. This is a real model name. To anyone just starting out, this is, well, it's intimidating. It feels like it was designed to be confusing, doesn't it? Yeah, it totally looks like someone just smashed their keyboard. But here's the secret. What if I told you there's a hidden logic to it, that every single part of that name is a clue, and it's not random at all?
Believe it or not, that mess of letters and numbers, it's not chaos. It's a map. A really detailed map, actually. And once you learn how to read it, you'll know exactly what you're getting. So let's learn how to read it.
Okay, so pretty much every model name you'll see breaks down into 5 main pieces. We've got architecture, parameters, training type, quantization, and format. We're going to tackle these one by one, and it'll all make sense soon.
All right, first up is architecture. The easiest way to think about this is like the model's family or its brand name. It tells you who built the basic design. You know, companies like Meta with their Llama models, or Alibaba with Qwen. And each family has its own personality, its own strengths and weaknesses.
Next, we have parameters. This is all about the model's size. You'll see a number followed by a B, and that B stands for billions. A good way to think about this is like a chef's recipe book. The number of parameters is like the number of recipes they know. The more recipes, the more capable the chef, but they're going to need a much bigger kitchen.
And that's the trade-off right there. A smaller 7 billion parameter model, yeah, that could probably run on your laptop, maybe needing around 8 gigs of RAM. But if you want to run one of the big dogs, like a 70 billion parameter model, well, you're going to need a beast of a machine with like 40 to 80 gigs of memory. Size directly translates to the hardware you need.
Okay, next up is the training type. This little tag is super important because it tells you what the model was trained to do. Now, for pretty much everyone starting out, here's the key. Look for the word instruct. It means the model has been fine-tuned to follow instructions, which makes it a perfect all-around tool for most tasks. You'll bump into a few other types too. Base models are kind of like raw cookie dough. They're for researchers to build on. Chat models are specifically tuned for that back-and-forth conversational style. But for most of us, instruct is the real sweet spot. It's the most versatile and useful one to start with.
All right, now for the part that honestly feels like magic. It's called quantization. And this is the secret sauce that lets us run these huge models on our regular computers. It's basically a compression process. It shrinks the model down so it uses way less RAM and runs a lot faster. Yeah, there's a tiny hit to quality, but it's what makes this whole local AI thing possible for the rest of us.
I absolutely love this analogy because it just clicks. An unquantized model is like a giant, flawless raw photo from a super expensive camera. It's perfect, but it's huge. A quantized model? That's your JPEG. It's way smaller, it loads instantly, and honestly, for 99% of what you're doing, it looks just as good.
So quantization isn't just one thing, it has levels. You'll see these labels like Q8, Q5, or Q4. The simple rule is the lower the number, the more it's been compressed. It's smaller, it's faster. For most people, the sweet spot, the best bang for your buck, is going to be right there at Q4 or Q5. It's the perfect balance of size and performance to get you started.
And last but not least, we have the packaging format. Don't let the name scare you. This is literally just the file extension. You know, like .mp3 or .pdf. In the world of local AI, the one you're going to see pretty much everywhere is GGUF. Just remember that name. It's the universal standard that just works with all the popular tools like Ollama and LM Studio.
So why is everyone using GGUF? It's simple, really. Everything you need is packed into one single convenient file. It loads up fast, and it's built from the ground up to support that quantitation we were just talking about. It just works. No fuss.
Okay, so we've cracked the code. We can actually read these crazy file names now. But that brings us to the most important question, right? How do you actually use this new knowledge to pick the perfect model for your machine and what you want to do?
Well, it really comes down to a simple checklist. First, what kind of computer are you working with? Specifically, how much RAM do you have? Second, what are you actually trying to do? Third, how patient are you? How fast do you need it to be? And finally, what's your end goal? Answer those, and you're pretty much there.
Let's start with the big one, hardware. This is a great rule of thumb to keep in mind. If you're running on a normal laptop, you're probably going to want to stick with models in that 7 to 14 billion parameter range.
Got a beefy desktop or a workstation? You can push it up to the 14 to 34 billion range pretty comfortably. And those monster 70 billion plus models, yeah, those are really for people with dedicated high-end GPU servers.
All right, next up, what's the job? I mean, you wouldn't use a hammer to turn a screw, right? Same idea here. For just general stuff, chatting, asking questions, stick with those instruct models we talked about. If you're a programmer, you'll want to grab a specialized coder model. And if you're doing really deep, complex analysis, look for a model that's known for its reasoning skills.
And you know what? Here's a bit of a pro tip. Instead of hunting for one massive do-it-all model, a lot of power users actually build a little team of specialized models. Think of it like this. You use a smaller, faster model for the quick and easy stuff, and then you call in your specialist, your big brain model, when you need the heavy lifting done.
So, what does that look like in practice? Well, your team might have a solid 14 billion Quen model as your go-to for daily chat. Then you'd have a dedicated coding assistant like DeepSeek Coder ready for when you're programming. And for really fast, simple tasks, you could use a tiny little model like Phi 3 Mini. It's a super efficient and crazy powerful way to set things up.
So think about what's just happened here. You're not just downloading random files anymore and praying they work. By understanding what these names mean, you're now making actual, informed engineering decisions. You're in control.
I really love this quote because it just nails it. This knowledge turns model selection from pure guesswork into systems design. It's a huge shift. You're no longer just a user, you're the architect of your own personal AI system, picking the right tools for the job.
So there you have it. We've handed you the decoder ring. You can now look at that map that once seemed like total chaos and understand exactly where you're going. The only question left is, now that you can read the map, what are you going to build?